Concentrated PV technology. There's a new, very advanced PV cells / systems, CPV, concentrated PV, and we can see the principle of operation on the left picture. The sun hits a dish. This dish is basically a mirror. It's what we call the primary mirror. Having this dish, we can see it also on the right side, but having a dish, the beam will be focused to a secondary mirror in the center, in what we call a focal point. And there is a secondary mirror there that will reflect the light on optical prism. This optical prism will concentrate even further, 1 additional degree, will concentrate the beams into a PV cell. So this small PV cell gets solar energy as much as the dish itself. Obviously, it will get hot. It will get hot to the point when it will be burned. It can get burned unless we will cool it. The way we cool the small PV cell on the bottom of the optical prism is by flowing water within it, inside it. One layer in that cell is basically pipes where water flows in the pipes. That's how we take the heat which is being generated. Because the energy is very condensed there, because the area is very small, this heat will be dissipated away by the water to cooling system, and having a closed circulated system, the water will be cooled outside and come back to the cell cold enough to dissipate the heat again. And this closed loop operation assures a fixed temperature of the cell itself. This is very, very sensitive. Let's keep in mind something very important regarding keeping the temperature lower but fixed. Any variation of temperatures, because this is a very high dense area and a small area of the cell having so much energy focused on it, any variation of temperature will burn the cell. This is why the water should be very, very pure / clean. The water pressure should be very, very well controlled. Any variation in that will burn the cell. So now, up until now, we talked about cell level. On the right picture, we see several cells connected together with this graphical presentation of the beams. On the bottom right, we see several modules. And on the left bottom, we see an array. That array, let's say for the sake of conversation, let this array is 4 meters by 4 meters. 16 square meters. These 16 square meters of CPV cells, concentrated photovolatile cells, have approximately 10 times more power capacity than a regular technology. Monocrystalline, polycrystalline, thin film. CPV is anywhere between 10 to 12 times higher efficiency, higher power than the other 3 technologies.